Hey guys, I think we are good to go here. Sorry, just kind of been messing around with a few settings. Is my sound is good? All right. So basically, what I've got today for you guys is I asked some people to just send some questions, and I've got a few bit of questions that I need to go through. If you guys want to access um, these questions, what you could do is, let me just show you guys where to go. Um, so that's the schedule, by the way. I have shared it on, what do you call it, on my community post somewhere. It's there. If you want access to the whiteboard itself, it's an online whiteboard. So just go to my website, under whiteboard, click on 2020 whiteboard. That should take you here. And if you click on level 3 calculus, you should get to level 3 calculus help desk, which is basically today's questions. So if you want to have a look at the questions that we're going to be doing today. At the moment, I've only got differentiation and complex numbers. So yeah, so we'll kind of get going with these questions. So some of them are achieved questions, and then we also have, what do you call it, a couple of excellence questions in there. Can you guys actually hear me, or am I just speaking to myself? Okay, sweet. Cool. So we're going to get started with a couple of basic achieved questions here. And then we'll jump straight into. So guys, if you do have questions, send it to my email, because some of you guys are sending it through Instagram and Facebook, and what's happening is the quality is dropping as I actually take the questions out. So it would be super handy if you guys actually send questions with high quality pics in my email. Facebook is not too bad, but Instagram is really bad for taking out photos. Cool. So what we're going to start off with is a basic differentiation question here. So as usual, what I'll do is usually I'll give you guys some time to work through, but at the moment, because this is kind of like a help desk, I'm just gonna power through the questions, and if you have any questions just on the chat on the side, just feel free to ask away, and I will kind of help you there as well. Just adjusting my screen, and then we should be good to go. Got it. Yes, this will be uploaded later. It will be saved on my on the playlist somewhere, so you can watch it anytime. Okay, so with our first question, what we have is we've got f of x is 6 square root of cos x. One thing that I would actually recommend you guys to do when you're working with square roots is getting rid of the square root symbol and just rewriting it as to the power of half. No probs, Neb. So once we get that part, we are going to be using the chain rule to differentiate this. So with chain rule, we're going to multiply by the power, which is half, cos x to the power of half take away 1. And I guess one of the things that people tend to forget is they always forget to multiply by the differentiation of cos x. All right, so you've got to multiply by the differentiation of whatever's inside the bracket in chain rule. So in this case, when we differentiate cos x, we are going to get negative sine x. Now, some people have always asked me this question: can I leave my answer like this? There's actually nothing wrong with this, leaving your answer like this, because in differentiation, they don't actually give you any extra marks if you simplify the answer further on. Like, you could potentially just leave this question as is. But one thing that I would recommend is just getting into the habit of maybe like putting a bracket in that power. Right, so if you do want to simplify this and you want to know what it looks like, it is going to look like this: 3 cos x to the power of negative half multiplied by negative sine x. All right, now look, I mean, we can just go about it in so many different ways of this, but I think I'm going to stop it for that one. So that would be like an achieved question. So yeah, moving on. Does anybody have any questions with that particular one, or can we move on? Cool. All right. So we're going to question number 2. Question number 2 is a derivative. Again, this will be again an achieved question, I would say. But just be careful. Like sometimes people tend to forget about product rules. Now, this particular question, it's a little bit annoying, but a really good trick to have for when to use product rule is kind of rewriting this almost. Like if I was to rewrite this, I'm going to rewrite this as f of x equals x squared multiplied by cos x to the power of 2. All right, and when I actually do this, I can straight away see that there is a multiplication symbol right there, which means I've got to start looking at product rule. All right, so with product rule, here I'm going to put down that I'm going to put u is equal to x squared, which means u dash is going to be 2x, and I'm going to put v equals cos x squared, and then v dash is going to be, you've got to use chain rule for this, so there's going to be 2 cos x to the power of 2 minus 1, and of course we got to multiply by the differentiation of the brackets, which equals to negative sine x. So I'm just going to simplify v dash a little bit, which means it's going to look like this: negative 2 sine x cos x. Now once I have that, then it's just a matter of substituting all of these things. So we can actually say that f dash of x is equal to u dash v plus u v dash. So we're going to write this down. U dash is 2x, v is cos x squared, plus u is x squared multiplied by negative 2 sine x cos x. Salty, I'm intending to finish the questions that I've been given today. So we've got, what do we've got? We've just done 2 achieved questions. I've got, that's an excellence question, merit, excellence, merit, and achieved. So yeah, I want to try and finish all of those questions. To send me questions, just email it to me, man. That's the easiest one. mattosc@gmail.com. We'll see how I go with this round. Otherwise, like I might actually, will you do more than these if we email today? Depends how long these ones take. I got about an hour and a half to kill. So if we finish these before that, then I could answer a few more questions. Otherwise, we'll catch it up with the next session. Okay, so any questions with question number 2 before we move on to 3? What, did you send a question for integration, TS? Cool. Let's go to question 3, guys. All right, I've got a few more questions from, yeah, those were achieved questions. Okay, so what we have is these types of questions. I know people, Friction, you're like, you hate it, but in reality, this is actually a really nice question, man. Just give me 1 second. I just want to pull. What do we have? Where did this go? Now, Rennie, this is yeah, we'll go through these questions, all right? This is an excellent question, but I just want to put up the marking schedule to see like what they give for achieved and stuff like that. DVDR found. Oh yeah, okay, that's not too bad. Okay, so what we have got here is like these types of questions, right? The formulas are given to you guys. Okay, let me just pull up the formula, and I'm going to show you guys how to crack these questions. Formula sheet. Calculus formula sheet. There we go. Give me a second. Let's jump through here. Jumping hoops at the moment. All right. So what we have is, if we go into the formula sheet, before I went back to the formula sheet, let's actually go back to the question. So the question actually says this, right? We're dealing with a cylinder. So he's designing a open top cylinder. That's the first thing that we need to know. So this is going to be an open top cylinder. All right. A good idea is to draw the diagram just to see what you're going to be working with. All right. Next thing is that she has enough money to make a tank with total surface area. So this is what we've been given. Surface area is equal to 12.5 meters squared. That's all she can do. And we want to find the height where the volume is max. All right, so this is basically what I've got from it so far. I want to double check. Are you guys all okay with that? What I've actually done there so far. Rebecca, if you send me any questions, I'm happy to work through them. At the moment, I've just got complex numbers and differentiations to go through. Cool. So here comes next step. All right. You're working with a cylinder. You've got surface area and you've got volume, which means we are going to go into our formula sheet. And most of the shapes that you work with, if they're like volume kind of shapes, they give it to you in your formula sheet. All right. So most of the time you're either working with cylinder, cone, sphere, and if they give you any other shapes, they generally tend to give you guys the formula. So in this particular case, we know that we're going to be using the cylinder one, which is volume. So I'm just going to take that down here. So volume of a cylinder is pi r squared h, and then surface area. Now the really important part to look at is this part here, where it actually says the curved surface area is 2 pi rh. All right, so let me go back to my little diagram and I'll show you guys what I mean by. So at the moment, they've actually got the 2 pi rh, which is the curved part of it. So that's actually this part here. No, Salty, these are questions that were sent to me by people, man. So I don't even know where these questions are coming from. I'm just trying to work it through. So now with the open top cylinder tank, all right, what we've got is we've got 2 pi rh, which is the side panel. All right, if you're gonna kind of open it up, that's your side panel right there. All right, and then we've got the bottom part of the cylinder that's there as well. That's the bottom part of it. So if we have a look at it, this right here is 2 pi rh. Now, if you want to know how that actually came about, remember that the height is this part right here. So that's what I've kind of like opened it up. And because you've got a circle and the radius of the diameter, oh God, circumference. The circumference is basically this part right here of the, like I'm going around, that's that length right there. So that's how you get that 2 pi r there. So if we actually look at what we have for the surface area, we've got that 2 pi RH plus pi r squared. Now this pi r squared happens to be that circle there, which is the base. That's the pi r squared. So what we've got here is we've actually got the formula for the surface area. All right, so the surface area now, this is all equal to 12.5. So are you guys happy with that part that I've done so far? Enoch, as I was showing earlier, you're given the curved part. So they actually give you the part that I've actually highlighted in light blue. So that's the curved part of it. So you've got to decide whether your cylinder, you're going to count the top and the bottom. All right. Now, we want to find the maximum volume, right? That means we've got to find an equation for volume, differentiate it, put it equal to 0, and that's it. Now, the issue is this. When we go to the volume equation, we actually have, we've got R and we've got H as well. Now, this is the problem, and this is what people actually tend to forget. You can only differentiate when all the letters are actually the same. All right. So if you have like a radius and a height, you can't actually differentiate it. So you have to write height in terms of radius or radius in terms of height. But you can't actually have like both of those things that are changing. You can't actually have it in the volume equation when you're differentiating. So our first priority is to get rid of the H. Good question, Ashford. But if you look at the part of the question where I've highlighted in yellow at the top, it's actually an open top cylindrical tank, which means I don't need the top. I'm only looking for the bottom, the side panel and the bottom part. Cool. So we have to figure out a way to get rid of this H that is, yeah, that would basically have got you a merit for that one, because if you did it as an open, like if you had that 2 pi r squared, yeah, that would definitely be, well, actually no, Ashford, if you kind of do everything right after that, they might consider it a minor mistake and give you like an E7 instead of an E8, because that's such a tiny mistake. But then if you did everything else correct after that, you might get an E7. But anyway, let's go with this part of this question. So we want to get rid of the H from the volume equation. So, and that's why we were given the surface area equation. So we have to rearrange the surface area equation where H is by itself. Because if you look at it, H right now there is by itself. So we can actually rearrange this. So this would become 2 pi r H equals 12.5 minus pi r squared. And then H is equal to 12.5 minus pi r squared over 2 pi r. All right, so now that we've got H by itself, which is this right here, we can actually take it and dump it in that volume equation. Because what would happen then is that we've got a volume equation just with radius and no heights. Because if you manage to do that, then this question just becomes a little bit more easier. So we're going to multiply by 12.5 minus pi r squared divided by 2 pi r. You could, Ashford, you could do that. It's, I mean, yeah, it doesn't matter where you simplify it. Eventually you'll have to simplify it whether you like it or not. So you could simplify H straight away, or you could bring it into the equation, and then I can start kind of simplifying it here as well, because here I can get rid of the 2 pi's, get rid of 1 r, and get rid of that r. So my volume equation now is equal to r multiplied by 12.5 minus pi r squared over 2. So expanding this out, I'm going to get 12.5 r over 2 minus pi r cubed over 2 . Yep, just checking I'm on the right track here. Gemma, the reason I'm able to cancel is because there are common factors in the numerator and the denominator. So guys, at this point, we've actually got the volume equation really nicely set up. So we're just going to differentiate this. So V dash is going to equal 12.5 over 2 minus 3 pi r squared over 2. Because that's why can't you cancel the pi in the brackets meant r? No, because that's inside the bracket. We're only canceling items outside the bracket. Because remember, this is exactly saying, this is the same thing as saying pi r squared multiplied by 12.5 minus pi r squared over 2 pi r. So I'm just kind of canceling that and that to 1 like this. So I'm not touching anything inside the bracket. No probs. So we've actually got the volume differentiator, guys. So all we got to do is we got to put this equal to 0 and rearrange and solve. So we're going to get 0 is 12.5 over 2 minus 3 pi r squared over 2. Rearrange it. I'm going to get 3 pi r squared over 2 equals 12.5 over 2. I can get rid of the 2's. I don't have to worry about it. So 3 pi r squared equals 12.5, and r squared equals 12.5 divided by 3 pi. So just going to go straight into here. What do we have? 12.5 divided by 3 pi. Gives me 1.326, which means r is equal to square root of that. Gives me 1.15. Now, the question actually asks, if you go back to the question, this is where people, again, you know, we all get excited. We're like, oh, we got the answer. We got 1.15 and we're good to go. I think you must have done a rearranging mistake there, TS. If you go back to the question, right, the question actually says this. You want to find the height of the tank. So what you've discovered right now is just the radius. So we got to go back to that formula that we have in the green box where it's height, and we have to substitute radius in it, which in this case is 1.15 squared over 2 pi times 1.15. Now here's a little trick for you guys. Like, see, 1.15 is you know, it's a recurring, like, it's a long ass decimal, and I don't want to round it up too early, but what I am going to do is I'm going to leave it as an answer here, and I'm going to do this. I'm going to go 12.5 minus pi multiplied, and I'm going to use the answer function and go squared, and then divide that by 2 times pi times answer. Ooh. So this way, what happens is that we kind of don't have to worry about rounding errors. And weirdly enough, yeah, h also in this case is 1.15. So grades wise, we're looking at DVDR found is achieved. So this would be achieved right here. Getting up to here gets you a merit. and getting this gets you an excellence, or I would say E8, which is 8 points. I wish I had the time to do those papers, man. I'm still haven't done the 2019 level 1 TEG and graphs. I got a whole lot of people that are asking me to do that. But I'll tell you what, we can actually do those questions as part of these help desks. So if you do have any questions, just pull it up and drop it, because I think some questions I've done from 2016, they're part of a series called Calculus Daily or something like that. But yeah. As for this question, are we okay with this? Any pressing questions? So if you guys remember, the way we approach this question is basically just having a look at, what was the information that was given to us? What are we looking for? And then going to the formula sheet to pick up the formulas, and then coming back and just substituting them. And I guess the key thing that I'm going to say is this, guys. When it comes to differentiating these kind of questions, it's this part right here, where it actually says volume is equal to pi r squared h. It's really, really important that when you differentiate something that you don't actually have two elements that are changing. Because remember, in this case, if the radius changes, the height is also going to change. So you can't have two things that are the same. And as long as you have that in your head, you have to look for the clues that are given to you on how you can get rid of it. And so in this case, we had our surface area that we knew that we could use to actually get h by itself. Qualification took me like 6 years to get my qualification. Like my 3-year degree took me 6 years because I just kept failing and failing so many times. But got just a bachelor's in maths. What if you did DVDH? Oh, that's a really good question, Ashwood. If you're going to do DVDH, then in this particular case, you would have to get an equation for r squared. All right. So, or you have to get an equation for r. And in this case, it's actually quite challenging, because look at this. When we have that statement, 2 pi r h plus pi r squared equals 12.5. If you are going to do dvdh, that means you got to get rid of r. And the only way you're going to get rid of r is you can't get rid of r in this case, because you've got r squared and you've got r, which means you've got a quadratic. So you got to solve the quadratic in terms of h, which is just going to make things very, very difficult for you. Now, Ben, I think the question actually said that you do not need to prove it's a maximum, so you're all good for that. And that's something to also to keep in mind, guys. Some questions specifically say to you that you do not need to prove, which means if they don't say it, you might need to just keep that in the back of your head that you might actually need to prove it. But it's just a good idea to always read the question. It comes sometimes, Zach, like on the odd occasion, they might just leave it in there. But you're right. I can't remember seeing it anytime soon. All right. So next up, I'm going to give you guys a choice. Do you want to do complex numbers? A couple of complex numbers questions, or still stick with differentiation? Two. Okay, let's go with differentiation. But like, look, if you're sitting calculus, you're probably going to do all three. So we might as well just keep going with this. I need to move some questions. What I might do is I might just do this question here because it's a nice, easy one to get rid of. Can go in the achieved sections. All right, so this is a really quick you should, Ashford, sorry, I didn't mean to ignore that question. Yeah, you should theoretically get the same answer, but the problem is to try and write r in terms of h is actually quite, you'd actually have a quadratic equation with h inside it, and so it just becomes very ugly looking volume equation. All right, so just keep that in mind. Like sometimes if you have a, like, to do a quadratic, if it was just normal stuff, then it's fine. But if it's actually with letters, it just becomes a little bit more complicated. Cool. So this question here is just a really, I think this is just an achieved question. And I just wanted to do it real quickly because it did pop up. So we're trying to find equation of a tangent. So first step is differentiating it. So we've got f of x equals ln of x minus 6x to the power of -1. All right, I'll just bring x to the numerator straight away just to make things easy for me. I'm going to differentiate this, which means I've got 1 over x negative times -1 times 6x to the power of -1 minus 1, which means f dash of x is equal to 1 over x plus 6 over x squared. Yep, that's correct, Darisha. Yeah, Derpet, I've been teaching for a long time, but can't you do 6 ln of 1? No? Why would you do 6 ln of 1? I think you're thinking about integrating, TS. Ashford, not necessarily. Cool. So here's the thing. Now this question is actually asking us to find equation of a tangent, all right? And to be honest, remember that for equation of the tangent, you've got y minus y1 equals m times x minus x1. All right. Now that equation again, is it given to you guys in the formula sheet? Let me just have a look. I don't think I've seen it. Oh, no, they do give that one in the formula sheet as well. Right at the top. You guys can see it. There we go. Equation of the straight line is given to you. Why do we multiply 6x by -1? So that's the -1 there, buddy. Because remember that when x is in the denominator, when you bring it to the numerator, it becomes x to the power of -1, and then I'm multiplying by the power in front and reducing the power by 1 as well. Cool. So what we have is, which part do you want me to repeat, Samuel? Yep, sure. We can do that as well, Gemma. All right, so let's actually do this one first. So here's the thing. We've got what x is equal to, right? We've got that x is equal to 1. So that's that right there. We need to figure out what y1 is, and we also need to figure out what m is. So what we're going to do is we're going to calculate f of 1 first. So f of 1 is ln of 1 minus 6 over 1. And ln of 1 is 0, so we're going to get -6. Now this right here happens to be the y value, which is -6. Yes, of course you can use calculators. Next thing is finding out f dash of 1, which is 1 over 1 plus 6 over 1 squared. So f dash of 1 is equal to 1 plus 6, which ends up being 7. And that is the gradient here. So to the person that was asking me about normal, I don't know who it was, somebody asked me about normal. So in this case, your gradient is equal to 7. So if you're working with a normal, then all you have to do is negative 1 over 7. All right, so as for this equation here, we've got y minus negative 6, which equals to 7 times x minus 1. So what we have got is y plus 6 equals 7x minus 7. So y is equal to 7x minus 7 minus 6. So y is equal to 7x minus 13. Okay. Sorry, just guys having a look at the quick comments. Yep, made a mistake. Cool. Is that all right with this question? And I think the person that asked me for a what do you call it? Normal. So you got to pretty much do the same thing, but except 7, you actually use negative 1 over 7 and rearrange, and you should be good to go for the normal of the equation. Are we okay with this question? Can we move on to the next one? All right, so let's go to a merit question. I want to finish off all the So this question here, this types of question, finding area under the curve, they're just annoying, but all it takes is just to kind of, go through step by step of what's actually happening. And I'll actually kind of show you guys how this actually looks like, because sometimes people don't see the demonstration, and because they don't see the demonstration, it doesn't actually make sense to them. So what's the equation? Negative half x squared plus 9. Okay, so this is going to be a little bit tricky. Tell you what. Let me just quickly. Can I do this quickly? Will it work? X equals to 2. I actually just wanted to show you guys how to do these types of questions, but now I'm thinking, should I just do it straight away, or yeah, let's just do it straight away. Doesn't matter. I'll worry about the diagrams later. Okay, guys. So when you look at this question, you're gonna know straight away. You're trying to find area of that rectangle, right? To actually figure out what's the maximum possible area of the rectangle. So straight away, you should know that you're actually doing base times height to get the area. All right, that's the first thing. So because we know that area of a rectangle is base times height. So here's the next thing to remember. The distance from here to here is actually x. Now, if for some reason you're like, oh, I don't know how to start this question, like what you could always do is take the point at the corner. We don't know what that point is, but we're going to call it xy. All right? And because that's x, we also know that the rectangle is kind of like symmetrical, so it's going to have a base is going to be ending up being 2x. And as for the height, the height of this rectangle also happens to be the same distance the same thing as y. So in other words, if you guys have a look at it, so my x, which happens to be the base, and the y value ends up being the height. But we know what the y value is. We know that the y value is negative half x squared plus 9. And because of that, we can actually write this as 2x times negative half x squared plus 9. And I think once you have that sorted out, then it's 2x multiplied by negative half x squared plus 9. Expand the brackets. We're going to get negative 1x cubed over 2 plus 18x. Nope, I'm wrong. I shouldn't have the 2 there. You're right, xlab, my bad. So what we have is area is equal to negative x cubed plus 18x. Now we differentiate. We're going to get negative 3x squared plus 18. And because area is equal to 0 for max, we're going to say that 0 is equal to negative 3x squared plus 18. Rearrange. 3x squared equals 18. X squared equals 18 over 3. X squared equals to 6. Now, we can actually put down x is equal to plus or minus square root of 6. But, you know what? We don't really have to worry about the negative square root of 6. All it's saying is that, you know, that the max happens at negative square root of 6 or positive. But we're only going to be focusing on the positive one. I'll tell you what, Kelly, I'll actually put an isosceles triangle after this just to show you. So once we've got that x is equal to square root of 6, then it's just a matter of substituting it back into the area equation. So our area equation is 2 times x negative x squared plus 9. And what I'm going to do is I'm going to put this straight in the calculator just to save time. So square root of 6. And I'm going to show you guys also another trick that you could do is to actually figure out how to get the max. But like, I don't know if it'll work, but we can try it out. So here I'm going to go 2 times answer, because that's 2x, and I've got negative 0.5 multiplied by answer squared plus 9 and close bracket. So that should give me 29.39 as my area. That should be my maximum area. In this, Gemma, you don't really need to worry about, you can just put it as unit squared if you want. They pop up as either merit or excellence questions tiers. I think I've almost seen like one pop up pretty much every other year. Now, to answer the other person's question, which was isosceles triangle under a curve. So let's say we've got this curve like this, and we have an isosceles triangle like this, for example, all right? So if you want to do this same, like let's just imagine that this is the same curve that we're working with. So negative half x squared plus 9. All right, let's just say we're working with this. Now, if you have an isosceles triangle, then what's going to happen is we're still going to do the same kind of idea behind it. So we're still going to take one of the points here, and we're going to call it xy, which means the height of this, and I'm going to show you guys a couple of variations of this question, all right? So just be patient with me. So the first variation is where the isosceles triangle is like this. Then your height of this triangle happens to be y. So for this one, you're going to get area is equal to half base times height. Now the base is going to be 2x. And the reason it's 2x is because you've got x there and you've got x there. Then you've got the height, which happens to be y. So because this entire thing is y, we're going to get half times 2x times negative half x squared plus 9. So that's for this type of situation where you have the isosceles triangle actually pointing downwards. But if you have the same question again, but this time we're going to have the isosceles triangle kind of going upwards to the top corner. Sorry, that's a terrible diagram, but you guys get it. We're still, again, we're going to do the same thing. We're going to call this point xy. However, in this one, there is one slight thing that you got to do differently. All right? Because if you look at the base, so the area of this triangle is still half times base times height. And the base is still going to be 2x in this case, because you've got an x there and you've got an x there. So that's going to be half times 2x. Now, here's where the kicker comes in. The y value is actually the length from here to here. All right, that's where the y value is. Now, in this particular case, this point was given to us as 9. And because it's 9, our height of this triangle is going to be 9 minus y. Okay, so that's something to keep in mind. So the only difference in this case is our height is going to be 9 minus negative half x squared plus 9, like that. I apologize, I've missed a whole lot of comments and questions there, but it depends, TS, where the base of the shape that you're trying to find is. Because if it's symmetrical, then yes, it's going to be 2x. But if it's not, it's going to be different. So no, Derpit, like if you look in the original diagram itself, like I think like they would usually give the point. I think I picked up the wrong point maybe, but like yeah, they usually should give you the yep, that's another way you could find it as well, Tarusha, is substituting 0 in that parabola equation to find out where the 9 is. But if you look at it, half x squared plus 9, 9 is the y-intercept anyway, so that's how I knew straight away. All right, guys, I'm guessing we're okay with this type of question and we can move on. Not necessarily XLab, because sometimes you have to be careful with, it all depends on where the position of X is. All right, so that's, yeah, I think we'll actually, I think I've seen another question pop up before. Okay, let's see, what other ones I've got left? I've got this complex differentiation one to do, but this one we'll do after I finish these couple of merit questions and complex numbers, and then we'll come back to that integration question. Right. This question here, I think I can see where it came from. 2013 D. I just want to check what you guys getting for grades. 2013 D. Ugh, God, it's an ugly proof. Ugly proof, but we gotta do it. So, how do we start this question? and you look at it, it's like this is such a horrible kind of question for a proof for a merit, you know. But hey, this is what it is. So, what are we going to do in this case? Well, let's have a look. We've been given u equals x plus iy, and that's our first condition. Our second condition is, and we've got au squared plus bu plus c equals to 0. Now we got to prove that a conjugate of u squared plus b conjugate of u plus c equals to 0. So I guess the first thing we got to try and do is, you know, if you have no idea of how to start this type of question, just substitute u as x plus iy inside that first part of the question and just expand, and something will happen. All right, that's the beauty of complex numbers, is that you're going to end up with something. And I'm telling you what that something is right now. And the clue is kind of here. It says that au squared plus bu plus c equals to 0, which means the real, I really need to use a smaller pen for this. The real part is going to equal to 0, and the imaginary part is also going to equal to 0. So that's something that we do know. So what I'm going to do is, because u equals x plus iy, I'm going to substitute it in. So I've got a times x plus iy squared plus b times x plus iy plus c. It actually says it's going to equal to 0. All right, because it's going to equal to 0. Now I know that the imaginary part of it and the real part of it is going to equal to 0. So all I got to do is I got to expand this. I got to expand it and put the real part equal to 0 and the imaginary part equals to 0. And I think, if I'm correct, expanded expression for equation in terms of x and y up to third line gets you an achieved. Yeah, so just expanding this out and simplifying it gets you an achieved. So, you know, it's not a bad question, just long. So I'm going to expand the x plus iy, which is going to be x squared plus 2xiy plus I squared y squared plus bx plus byi plus c equals to 0. So here I've got a x squared plus 2xiy minus y squared plus bx plus byi plus c equals to 0. So expand the bracket out. I've got ax squared plus 2axyi minus ay squared plus bx plus byi plus c equals to 0. So from here, I'm going to put all the real things together and put all the imaginary things together. So my real, and again, a good idea is to have a highlighter ready for these kinds of things, because I always end up missing a term sometimes. That's real, and that's real. So basically what I'm going to say is ax squared minus ay squared plus bx plus c equals to 0, and 2axyi plus byi is also equal to 0. So those are the things that I've established from the first part of the question. Now I need to actually go to the second part of the question and actually prove that A conjugate squared and blah, 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 and all of that. So for the second part, I know that U equals to X minus IY. So because of that, what I'm going to do is I'm going to have to do the whole thing again, I believe. Yep. So I'm going to go A times X minus IY squared plus B times X plus X minus IY plus C equals to 0. What up to I squared inside the bracket? 1, Ashford. U conjugate. Salty, you okay with that? So anytime you get a little symbol on top of the letter, that just means that you just put the conjugate of it. Oh yeah, sorry. Yeah, my bad. Sorry. Silly me. Cool. So I'm going to expand this out now. So kind of same process again. So A, I'm going to get x squared minus 2xyi plus I squared y squared. So far so good. Yep. And I've got plus bx minus byi plus c equals to 0. Then I've got a times x squared minus 2xyi minus y squared plus bx minus byi plus c equals to 0. Yeah, I have, Micah. I haven't done one of them yet. So ax squared minus 2axyi minus ay squared. Kind of keep going. Okay, so at this point, I'm going to go back and collect my real things again, exactly what I did before. So that's real, that's real, that's real, and that's real. So when I put it together, what you'll notice is I am getting the exact same thing I got in the top as what I'm getting it here. So I can actually say equals to 0. Might just put like a little note from above. And then my imaginary parts, I've got 2axyi minus byi. Now, the only thing is, take the negative out. So it's going to become negative 2axyi plus byi. And what you'll notice is since this part is equal to 0, I can actually put this is equal to 0, which will become minus 0 and 0. So we proved it. That, yeah, that's it. There's nothing else. What does it say? 0 as required. That's all. That ends up being a merit question. Well, negative 0. Negative times 0 is just 0. Derpit, proving questions are actually really good in complex numbers because like you literally just have to mess around with it for a while, and eventually it's just knowing when to substitute, when to change things up so that it ends up working out. So I reckon, like, you know, if you guys get proof questions in complex numbers, I'd say you're super lucky because it's at least you know that you've got to try and get to that answer, and it's just a matter of kind of playing around with it. So my recommendation is, like, if you guys go back to the past exam papers and have a look at a lot of those excellence proof questions, it ends up being that yeah, you just become fairly good at it after a while because you just have done so many of them. You know all the tricks and tips. Well, not necessarily. Like, see, in terms of time management, what I actually say is that if you're spending more than 15 minutes on an excellence question, then you've got to make sure that you at least try and get like a E7, because that's like, otherwise, you know, you've got to make sure you get the M6s, the two M6 questions correct. Because remember, for excellence, you need like 20 points, 20, 21 points, right? So I would actually say pick one excellence question that you absolutely know how to do it, and then those other, make sure you get like M6s in the other questions, so that kind of gives you a good strategy in terms of getting the highest points possible, or for sorry, the lowest points possible for an excellence. All right, so can we actually go on, move away from this question, and jump onto this question here? This is a merit question again in complex, and I would actually say that I've seen it pop up almost, yeah, I've seen it pop up almost every single year, unless they've changed like slight different variations of it. Michael, there is what do you call it? Like, I actually tell guys to go backwards, in the sense of, like, if you're trying to aim for excellence, there's like two strategies you can do with this. You could actually go do all the achieveds first, because achieved questions shouldn't take you that long. So if you are spending more than 2 minutes on an achieved question, then I would almost say just drop it and move on to the next question if you're trying to aim for excellence. But again, we'll spend a little bit more time, maybe spending like half an hour one day, where we just talk about what's the best strategy in terms of what points you're actually going for. Yeah, Ryan, I had a student of mine that did it once, where he did just the excellence questions, and he spent so much time on it that he didn't back himself with a couple of the merit questions. So he actually got 2 excellence questions correct, and in the third one he got 0 points. Oh no, he got an N2, I think. And because he got an N2, he only got a score of 18 and ended up getting, I think, 1 short of an excellence. So you got to backtrack and make sure that you cover those merit questions just in case you don't get that excellence one. All right, so let's have a quick look at this question here. So what we've got is, we've got to figure out what A is. Now the first part of this is that it actually tells you guys that one solution to this equation, yeah, this is complex, Revish. It actually says that one solution is that. So your first part is to figure out the A value. All you got to do is substitute -2 in straight away as W. So you're going to get 3 times -2 cubed plus A times -2 squared minus 3 times -2 plus 10 equals to 0. So what we've got here is 8 times 3 is 24, plus 4A plus 6 plus 10 equals to 0. We have 4A plus 40 equals to 0, which means -40, and A is equal to -10. So doing this it's going to get you achieved straight away. All right, just figuring out the A. Now the second part of this question, The second part of the question is you got to actually, oh, sorry, yeah, good point. This is what happens when I try and rush through things. Negative 24. Let's try that again. So what do we got? 4a 16 minus 24 minus 8. Have I stuffed this up completely? Am I on the right track? Sorry, I kind of was talking and stuffed this up. Does that look better? A equals to 2. Anybody backing me on that? Sweet. Yeah, so basically this question here, I'm not sure where this question came from. I'm trying to think. Was it, but like, look, here's a little cheeky trick that you can do, all right? So because this question here, it's 3w cubed plus 2w squared minus 3w plus 10. Here's the cheap little way of doing this. Go into menu, all right? And what you can do is go into run mode and click on shift setup. Now in here, it's going to ask for complex mode and it says real. Just change it back to a plus bi. Then go into equation, polynomial, degree is 3, and we're going to put this in here. So we got 3, we got 2, we got minus 3, and we got 10. So when we do this, we actually end up with these things as our answer. Now, I just want to double check. Have I made a mistake here? 3, 2, negative 3, 10. Yeah, Salty, it's fine. I just want to have a look at the answers for this particular question, because it's like, I mean, the other way of doing this without the calculator, it's a long way, but I'm trying to think, who was it? It's 2015. Did you guys say 2015 this question was in? 2014. 2014. C. No, it's not 2014. Must be 2015. Let's have a look. Yeah, 2015 C. Yeah, looks like we have to do long division in this. Let's have a look. Now, friction, it's achieved to actually try and get the A value is going to be achieved, but the rest of it is going to be what do you call it, merit. But yeah, see, the thing is, like, I think when they gave these questions in 2015, they didn't actually realize some of these questions you could just punch it directly in the graphics calculator and just do it. Because when I look at the answer schedule for 2015, they basically say for achieved you need correct value of A and then correct solution. But I'll actually screenshot one of the answers. This is from the actual schedule, so that Where is it? Sorry, I'm just trying to find. Where? Oh yeah, here we go. Yeah, it's really weird because it's like in the answers they've actually said that they actually accept an answer of 0.667 plus 1.1055i, which basically means that they would have expected people to do this by graphics calculator, and they could actually get a merit for that. But since we've got time to kill and we actually want to know how to do this the long method, so the long method is this. First thing is this: if w equals -2 is a solution, then we can say w plus 2 is a factor. So yeah, one root is w plus, well, not one root, it's one factor. Root is the solution, is the root. So then what we have got to do is we got to do w plus 2 and long division of 3w cubed plus 2w squared minus 3w plus 10. Now there is something called synthetic division, which I've kind of brushed through a couple of times, but because I've done long division from the time I was a kid, it just makes sense to me. But I haven't actually done a video for synthetic division, but it is still, you can still do it. But I'm trying to think, Salty. You can't guess and check in this case. You would have to do it. You'd have to do it long division. There we go. There's that answer sheet that I told you about popped up. See, it's like you have to do long division to actually to try and figure out this part, and then after that you go and put it in the quadratic equation to try and get a nice looking answer. But if you are doing long division, since this has taken over my space, let's just move that. So how it works is, I'm going to kind of just go through this real quickly, guys. I'm going to go 3w times w is, 3w squared. So that's 3w cubed plus 6w squared. Then I've got to subtract. I'm going to get negative 4w squared minus 3w. In this one, I'm going to multiply by minus 4w, which is minus 4w squared minus 8w. Minus 3, that's going to be 5w plus 10. And I'm going to multiply by plus 5. 5w plus 10. So, long division, yeah, practice, that's all I can say. Synthetic, yeah, it does make sense as well, but you do need long division, guys, because it also helps you with, as TS was saying, it does help with integration as well, especially integration by where you have like a when you have something like this, something like that. Yeah, it does help to know long division when you want to integrate a function like this. Okay, as for this, we get 3w squared minus 4w plus 5. So our two, we've got one of the factors like that. The other one is 3w squared minus 4w plus 5 is equal to 0. And because we have a quadratic equation here, we simply put this in the quadratic equation with minus b plus or minus b squared minus 4ac over 2a. So I'm not going to actually keep going with this question, guys, because from this point onwards, as you can see, it is just substituting it and then rearrange. Well, you don't even have to rearrange, just get those two solutions and you're done. Yeah, a couple of annoying little complex number questions. Thanks, man. But I tell you what, like it just covers quite a bit of skills as well, so it's not a bad couple of questions to do at this stage. All right, so can we move on from this question? No worries, dears. So salty, as I said to you before, like, yeah, you can in this, since then they've changed how they ask this question. Like they don't actually ask it so that you can just plug in the values in the calculator and just get it straight away. They've changed it, so they ask like different questions, so it makes you think a little bit more. Yes, you're correct, Revesh. It does have 3 solutions, because remember, when you do the quadratic, you're going to get plus or minus. So that's the number 2 and 3 solution. In this, Thurshov factor theorem would not help. The reason it won't help is because the number that, as you can see, we've got this ugly looking solution. There's no way you would guess and check, put that in the factor theorem. It depends, Michael. It depends what type of question it is, because each question you've got to approach it differently. All right, guys. So I've got one more question to do. And I think I'm losing my voice at the moment, so I might just call it after this last question. But it is a very long excellence question. What I can do is should I just start you guys off on it and then kind of go through it, or should we just go through the whole thing? Actually, that's a good question. Let me know if you guys want me to actually go through this question, or do we go start this question next time around? Because I know we've just had about nearly an hour and 20 minutes. Bugger, let's get it done. At least that way we can finish off on this question. All right, so this question here, another one of these long questions, but it's again about breaking the question down. All right, this is differentiation, by the way. So what we've got here is she is going to be paddling a kayak from point A on one bank, which is 3.5. What is the actual question? Micah, did you actually send me the whole question, or was it just part of the question? Oh, actually, no, it is there. Oops, sorry, I just didn't read it properly. No, Micah, you're good. It's there. It's just really hidden. That's what we're looking for. We are trying to figure out at what point she needs to cross so that this could be all as quick as possible. Now, this particular question, guys, I'm going to kind of break it. I'm going to break this question. Really? That's interesting. I'm going to break it into like 3 different stages so that you kind of understand what's happening with this question, okay? So the first stage is this. Point A, point B, point C, and then stage 2, point A, point C, point B, and stage 3, A, and directly across to C and B. Just give me 1 second. I'm just going to explain to you guys what's happening here. Okay, so so basically the situation is this, right? So she can actually go in her kayak from point A to one bank to the other side of the bank. So I'm going to show the first one. So in this part, she takes the kayak, which is the green. Oh, shouldn't have used green. I'm going to use something else. I'm going to use pink for the kayak. So she's kayaking on the river, and then she crosses it, and then she decides to actually walk the rest of the distance. All right. Then the second situation, she actually kayaks a little bit further, and then she walks. Or the third situation is she actually kayaks the whole way through. All right. So at the moment, those are the kind of three situations that could potentially happen. Now we are trying to figure out which one is going to give us the least amount of time to travel from A to B. Are you guys happy with those three situations? Like what's happening there? Cool. So the next thing is this. It actually says that her speed, she can paddle at 5 kilometers per hour. So that's the water speed. And then she can run at 8 kilometers per hour. So that's the next thing. Now, if we have a look at 6.5 is the distance. I'm actually going to be looking at the middle one here. So that distance right there is 6.5. What I'm going to do is I'm going to use this particular one. If that is 6.5, then the distance from here to here, the orange part, I'm going to put that as x. So basically, I'm going to create something like this, where this is x, this is 6.5 minus x. All right. Now, the other thing that we also know is this is 3.5. And I think once you get all of that, we can slowly start kind of breaking this thing down. So we want to actually first figure out what's the distance she is kayaking. Now to do that, we've got a right angle triangle, and we're looking at the hypotenuse. So that pink part there is going to be square root of 3.5 squared plus x squared. So are you guys happy with that? So once we have that, so we're going to have kayak distance divided by the speed is going to give us kayak time plus running distance divided by speed is going to give us the run time. So if we look at the kayaking distance is that I've highlighted in pink. So that's going to be square root of 3.5 squared plus x squared divided by the speed, that's at 5, plus the running distance, what did I color that? Blue. That's 6.5 minus x. So that's going to be 6.5 minus x, and now that's divided by 8 because yeah, that's going to give us the time. Wow, Tampa. So guys, are we okay with this so far? Because I think this is possibly the most challenging part, is actually to come up with the equation. Because once you come up with the equation, then everything becomes easy after that. So this is what our equation is for total time. So if you want to find out what the total time is with what it is, you just got to differentiate and put it equal to 0. So I'm going to find out what time is, but I'm going to rewrite it nicely so that differentiating it becomes a little bit easier. Yep, that's what I have. I'm just double checking that I'm on the right track. Looks good so far. It's a practice exam, yeah. But I mean, it is possible that you get a variation of these types of questions. So I'm going to differentiate it now, which means I got 1 over 5 times half 3.5 squared plus x squared to the power of negative half, multiplied by the differentiation of whatever's inside the bracket, which is 2x, plus 0 and minus 1 over 8. So we can actually say that time hash is equal to 0 for minimum. So we're going to put 0 is equal to, I'm just going to kind of get rid of a few things. So I've got 2x over 10, 3.5 squared plus x squared to the power of negative half, minus 1 over 8. So at this point, all you got to do is just rearrange. So you're going to get 1 over 8 equals 2x over 10. I'm not liking this question at all. I'm not going to lie. That's what I have. Why do you guys give me these questions that make me suffer? Give me a second, guys. Okay, dt dx found. We've found that. That gives you an achieved. Really? All that work for an achieved? That is just sad. Man, all that work up to here gets us an achieved. dt dx, putting it to 0. Oh, wow. This is a question that just keeps giving. Okay, so putting it equal to 0, attempted to solve gets you a merit. Oh, attempted to solve gets you a merit. So I think even just putting it and then attempting to solve it gets you a merit. That's lovely. Yeah, it is a long question. That's why I said like, but anyway, let's just keep going. As much as it pains me to do this, it's like, okay, so get rid of that. So we're going to get 1 over 8 equals x over 5. I'm going to move this 3.5 squared plus x squared to the power of positive half. Cross multiply everything. So I've got 8x over 5 is 3.5 squared plus x squared to the power of half. Now, I got to figure out a way to get rid of that half. So because I want to get rid of the half, what I'm going to do is I'm going to square both sides. And when I square both sides, I'm going to get 3.5 squared plus x squared equals 64x squared over 25. Rearrange this. I've got 3.5 squared equals 64x squared over 25 minus x squared. What is that? 64 minus 25. See, you know it's late when I can't even do that in my head. 14, 9, 41. Why can't I do this in my head? This is when powers start waning. I don't want to do it wrong, that's why. Ah, there you go, 39. Jeez. Can't even do that. 25, and then x squared equals 3.5 squared multiplied by 25 divided by 39, and this is what x squared is going to equal. So 3.5 squared times 25 divided by 39 gives us 7.85, which means x is equal to square root of that, which is 2.8 seconds. Yeah, that's me done. I missed all of the chat sessions there, but we got somebody from Florida. Nice. No worries, Stephen. Yeah, that always happened towards the end of the last question. Yep, Dirpet, I think we've got another stream coming this week. Why is it 65 minus 64 minus 25? Oh, the reason I did that was because this part right here, I just did 64x squared over 25 minus 25x squared over 25. So just to combine the fraction. I'll just chuck my live stream timetable, guys. Give me 1 second. Can just jump over. There you go. That's the live stream document. I'll also put it on chat so that if anything changes, just keep an eye on it, that document. If anything changes, I'll actually put it up there. Anna Latu, no, this was actually a differentiation question, which was just a really long differentiation question. So back again Monday, Tuesday, Wednesday. We're back again Wednesday. Now I'm done, TS. I've lost my voice. I was actually planning to do another video today for level 1s, but my voice is cracking. Can only speak for 1.5 hours straight a day. So guys, I noticed that I've got question from a couple of other people, Connor and Kelly. I will go through these questions from the next time around. I'll just put it up on the document. So what I will do is just to give you an idea, I will chuck it up in this document. It should be under help desk 2. I'll just create it and I'll put your questions there. So guys, if there's any questions from 2018 or 2019 papers, just letting you know that I won't be going through them because I've already made videos for it. But if it's anything before that, it is fair game unless I remember making a video for it. And if that's the case, I'll probably just let you know. Okay, so yeah, that's basically it. The questions that are coming up next for the next time around, what do I've got? I've got a isosceles triangle, a water tank question, which I thought I've done. Oh no, that's a good question to do. Yeah, I haven't actually copied it over yet. I'll copy it over later. And we've got, yeah, I've got another one of these long word differentiation question from 2018. All excellent questions by the looks of it. Geometric reasoning or geography? The water tank question is a differentiation one. See you, Galaxy. Good for you to join us. What's this no brain thing you guys are talking about, Zach? No worries, Andy. And practice, lots and lots of practice. Just keep practicing those exam questions. All right. Revish, level 2 kinematics. Come on, man, we did that back in pandemic time. Salty, it depends, man. The papers all change all the time. Like, I know last year I thought complex was actually quite nice. And the previous year, I think it was differentiation that was really nice. I can't remember now. So, anyway, yeah, actually, Salty, yeah, practice as many papers as possible, man. I think that's the best way to go about doing these exams. Otherwise, you end up, yeah, just not. Where are we at? There we go. I didn't realize I was showing the wrong thing all this time. Oops, my bad. Cool. Anyway, I will leave you guys to it, and I'll catch you guys back on Wednesday. All right. Just keep sending those questions because it's easy for me to just do the questions that you guys send me rather than me creating these questions. Who are you talking about, Harit? Yeah, sorry, Jaspreet. Yeah. I'm from Auckland, Harit. Zach, yeah, that was hard work. I'm actually gonna go back and do it again, man. Um, I had a good time training, but anyway, look, I'm gonna get some shut eye, guys. I will catch you guys on Wednesday. All right, just keep up with the questions, and I'll group them together. And do send some integration questions because I know people we didn't even touch integration today. It'll be good to get some integration questions under the belt as well. Cool. Have a good one, and I will catch you guys later.